Hi, I'm Wim Provoost. I'm a product manager for vStorage, a product by CloudFounders. That's the reason why I'm wearing this shirt, actually. So it's an open source project. It's not something that's done in a shed by two guys or in a basement by two guys. It's an open source project where actually people are working on it. There's actually people being paid. CloudFounders is paying for the flights, is paying for the venue, for the food, so it's not a hobby project. That's the first thing I want to explain, because a lot of people think open source, that's like two guys doing some fun, but it's a real product, a real project. And because it's the sponsor, I'd first like to say a few words about what we are actually doing as a company. So the first thing we do is we build technology, and that's our open source project. It's what we've done is we've been in the private and the public cloud business for more than 4 years now. It was even before we called it a cloud that we were doing things like cloud computing, and we've built technology. And we thought, okay, this is really great technology. So why keep it for ourselves? Let's open source it. Let's have more eyes looking at it, and that's why we open sourced our core technology, which is called OpenStack. This is what I'm going to be talking about tonight. And of course, if you just do open source technology, you don't make any money, so you have to build products around it. So that's why we have VRun. And VRun is our product. And a product, it's a converged infrastructure that we're building. So this is a private cloud that can be implemented inside your own data center. Now, if you're a small shop and you don't have a lot of knowledge about maintaining infrastructure or maintaining your own cloud, we can also do it for you. So we have a service which is called FlexCloud, which means we do it in our data center. So you rent space in our data center. You own the hardware, and we take care of everything. We set up everything. We do the monitoring. We do the patching. The only thing you have to do as a reseller is resell that capacity like you would do on AWS. So that's kind of what we do in a nutshell as CloudFounders. As you can hear, we're a Belgian company, so I'm from Belgium. We're a Belgian company, but we have a worldwide presence. We have sales offices in the US, in California. Headquarters is in Belgium. We've got stuff in Romania and also in Mumbai, India. Before we get started, I'll first like to take you back to the basics of storage. I guess most of the people here in the room will know about storage. There's block storage and there's object storage. And typically what you will see if you go to a vendor presentation from a block storage vendor like NetApp or EMC, or you go to an object storage vendor presentation like from SwiftStack or like CleverSafe, Data, Scalability, you will see that there's like this type of slide. And typically there's a line in between or even barbed wire in between. It's two different things. That's what people try to, or what people want you to believe. The first one, the block storage, it's the high expensive storage. It's the very fast storage. It's for virtual machines. It's small capacity, limited capacity. It's a rack of nodes, and you have all funky functionality like zero copy snapshot. All the expensive or all the fancy management stuff around storage are implemented in there. And on the other side, you've got like the complete opposite. We've got something which is massively scalable, an object storage. It's cheap because they're doing it on cheap disks, on SATA disks, which are 8 terabyte these days. They don't have high-end management features. An object store, that's simply doing a put and a get. That's the only thing you can do. There's no RAID or something like that, or a volume or snapshot. That's all not implemented. It's just to get and a put. And it's low performance. We're using slow disks, so it's typically slow performance. Now, what we envisioned with CloudFounders is we are having our own, or we have a storage problem, and the problem is actually, since we're running our own private clouds for customers, we have a demand for storage that keeps on growing, and we kind of quickly realized that we need to go with object storage, because that's scalable. But on the other hand, we wanted something that was also very reliable, very performing, So we kind of needed something which was in between, because we're running virtual machines for our own customers, so we wanted something in between. So we looked at the market and we said, okay, there's nothing in the market that does this, so we're a technology company, so let's do it ourselves. So what we said is, let's build technology which offers the features of a high-end SAM, like an NetApp or an EMC, but also gives you the features of object storage, like unlimited scalability and the low cost. So that's kind of the idea. So this is Open vStorage. So Open vStorage, in a nutshell, it's an open source software platform which builds a highly scalable, highly reliable, VM-centric, which means that you do things on a VM level base, not on a volume level base, on top of an object store or on Seagate kinetic drives. I've already done some shows and I've already noticed that not a lot of people know what Seagate kinetic drives are. Is there anybody in the room who knows what a Seagate kinetic drive is? They are 4 terabyte drives, but instead of, they look like a normal SATA drive, but instead of putting them in a normal chassis, you connect them to a switch. So it's disks which have an IP address, which is pretty cool because that means that you can just take a bunch of disks, you put them, you connect them to a switch, and you've got a pool of storage that you can manage, which is insane, which means that you don't have to invest in RAID controllers or things like that. So it's really cool technology. It's very new. They released it on the end of last year, and it's something if you don't know about it, you should look into it if you're in storage. Okay. So when we designed Open vStorage, we had some features in mind that we definitely wanted to implement. It had to be hyper fast. It had to be scalable. It had to be reliable. It had to be VM-centric, open source, and of course we wanted low cost. The reason why we chose VM-centric is because in that case, you do actions on a VM level, which means that you don't have to hire expensive storage administrators, but you can get away with people who are less advanced in storage industry. And that gives you a much lower TCO, of course. Now, how does it actually look? How does it work? Well, this is the basic architecture of an Open vStorage implementation. So you have your nodes, your OpenStack nodes, which are running Nova. And that means that your virtual machines are running there. We also have the Open vStorage software running there as a software component. And what it will do, it will use the SSDs, which are inside that OpenStack Nova host, and use that as Tier 1 cache, as fast storage, which means that if your virtual machine, if you're doing a writes of your virtual machine or inside your virtual machine, it will go directly to an SSD or to a PCI flash card, which means that it's hyper fast. It's the fastest you can get. Also, next to write caching, we also have a read cache, which means that if you have to read something for inside the virtual machine, it's also fast. Because yeah, that's typically the fastest technology that you have, like an all-flash array. That's typically the high-end stuff that you get. So this is something that we do also on the front end. We do this inside the host, so it's very close to where your virtual machine is running. And for people that know, for example, things like Nutanix or like Simplicity, like the hyperconverged guys, well, this is what they had. This is what really is good about their solution, because what they do is they keep where your virtual machine is running and where the storage is, or the storage of your virtual machine, they keep that close together, which means that you don't have latency, you don't have like problems with network capacity and things like that. So it's always hyper fast. So we said, okay, this is a good idea, but what we didn't like, well, we didn't like that they also put the second tier of storage. So when data is no longer needed inside the cache, they put that also on the same box. But we said this is not scalable, because if you know that compute power and storage, well, storage will scale 3 times as fast as compared to compute power, which means that you need 3 times as much as storage space compared to compute power. So we said, let's take it out there and let's build something which is compatible, also S3 compatible, so which uses something which is S3 compatible, or a pool of kinetic drives, and let's store all data on top of that, which means that of course you You have endless scalability. You just put in more disks, and you are set. It just grows whenever you need it. So that's kind of the basis. So on the front end, we have a location-based storage system. It's a unified namespace, which means that if you have multiple hosts, every host sees the same namespace, sees the name. They think it's like a shared NAS, shared storage, which means that they can do things like live migration, like high reliability. That's all possible because it just scales out. And so that's the front end, and that's really the block-based storage. So this is where your virtual machine will typically see its block storage, and then we transform that into object storage on an S3 backend. So that's kind of what I have to say about that. If there are questions, just shout. Or discuss that. Yeah, okay.
So what type of file system are you running to support that? Sorry.
What type of file system do you run to support the unified namespace?
The unified namespace, well, on VMware we use NFS. On KVM we currently use Fuse, but we noticed that these two are not really optimal. They give a bottleneck. Well, it's for what we're doing, it's fast already, but we think we can do better. So what we did is in a new version, the upcoming version, which will be released end of Q1. We will have PureDisk integration, which means that we don't have the file system like overhead anymore, and we will just have pure performance going directly to the SSDs.
Do you pull everything through the cache on reads on the SSD?
Yeah, yeah. Which means, of course, that if you will need an enterprise SSD for the read cache, because every write happens on there, so it needs to be very fast. So typically we use that, for example, like something like a Fusion IO or an Intel, like a more expensive drive. But what we do is, since we split up the read cache and the write cache, for the write cache we use that expensive SSD. For the read cache we can get away with less expensive SSDs, because what we've done is we've actually built a deduplicated read cache, which means that if you have multiple virtual machines, you store data which is common between those virtual machines only once. You have a big hash table, which means that, okay, since you're managing a hash table, you don't want to have many changes, because otherwise you have to recalculate it and manage it, and that's a nightmare. So that's why we use that hash table. It doesn't change a lot, so there's not a lot of writes happening, which means that you can get away with less expensive disks and still get the performance, because you're not handling them that much like you would do with a cache. So it means that you save a lot of money, for example, on SSD storage, because you only have one expensive SSD.
Are you considering Ceph as a Ceph?
Okay. Okay. So how does Ceph picture inside this architecture? You have basically, if you're now running a traditional OpenStack, what you will do is you will have your Nova nodes. You will use a Symantec plugin, and that will talk to Ceph through the Rados gateway. We think that we can do it better. As you know, or people who don't know, Ceph has an S3 compatible interface. Next to Rados interface, which is the block interface, they also have an object store interface. We believe that's the way to go. So if you have Nova, you take Cinder, you put us in between, and then you go to Ceph. That's how we envision it. And there's 3 reasons why this is a much better solution compared to running Ceph, like OpenStack with Ceph together. First reason is performance. The way how we are doing caching is a much better way than Ceph is doing with a cache pool of disks, because you already hop down the network. What we do is we do caching locally, so that's already a huge performance hit, a huge performance benefit. The second reason why we think vStorage together with Ceph is a much better idea is the fact that you can't do erasure coding if you use the Rados gateway. Let me explain that. If you use the Rados interface, that gives you blocks of 64 kilobyte. And what you want to do with that is you want to erasure code it, because there's 2 things you can do with an object store. You can erasure code, which means that you take data, you split it up in a couple of smaller objects, and you add some parity. It's like you would have with RAID. but then you split it up across all the disks inside your storage platform. The other way is doing three-way replication. So if you have an object, you just copy it 3 times, which means that it's safe against disaster. Now, typically we'll see that if you use erasure coding, you will use half of the storage that you would use in case you would be using three-way replication. Now, since Ceph is using blocks which are small, 64K blocks, you can't erasure code them. Because if you erasure code them, a small block, you chop it in smaller blocks, you add some parity bits, you have to store that. Well, that means that you're storing a lot of very small objects, which just means that your metadata will explode. So that's something that you just can't do. You will hit the limit that Ceph was designed for. Ceph is designed for a reasonable sized object, not for very tiny objects. So that's why it will never work using the Rados gateway, Rados interface together with erasure coding. So you have to go with three-way replication, which means that it's 2 times more expensive. So if you're having as much data as we are having, it means that your cost is really significant higher. So you don't want to do that. So that's why we say that's not a good idea to do it. And the third way, the third reason why we think that OpenStack storage with Ceph is a better combination. Because Ceph is for the people that are running VMware. I almost have every week somebody on the phone that wants to run Ceph together with VMware. Ceph together with VMware, that doesn't work. Red Hat, who owns Ceph, will never write something that will work with VMware. They would be stupid doing that. There's lots of questions for it, but they will not do it. So if you want to use VMware together with Ceph, the only way to do that is use us. So then we are playing the middleman or the translator between Ceph and VMware. So that's the 3 reasons why Ceph together with OpenStack storage is a much better solution than just having Ceph alone. Okay, so back to where we were. OpenStack storage, it's really about an optimized storage architecture. So the first thing we do is we use SSDs and PCI flash cards inside the host to do the caching. Just make sure that it's fast enough. We use a deduplicated read cache, as I already explained. Of course, we do things like all the high-end SANs do, like thin provisioning, zero-copy cloning. That's all functionality that's included. And one of the nice things we can do is, since we are pushing data which is no longer needed outside of the which is no longer needed inside the tier 1, inside the flash, we push that down to the storage backend. And we typically store all the data, so every write that has happened to that virtual machine gets pushed down to that storage backend. What we do is for every write that happens, we write it on an SSD, but on the SSD we have a log-based, always append system. So every write is appended to a file, and once we have enough writes, typically 1000, we push that down to the storage backend. So that means that we've got every write inside that VM stored on the storage backend, which means that things like snapshotting or maintenance tasks that you typically spend IOPS, for example, if you have an all-flash array, you will spend IOPS to do snapshots or backups. Well, we can push that functionality down to the second layer, to the tier 2 storage, which means that you're making better use of your tier 1 storage. So that's also a big benefit. Scalability. Since we're managing our own clouds, we tend to grow. So that means that we have to take it into account. And what we wanted to do is we wanted to scale. We wanted to scale along 3 dimensions. We wanted to scale compute capacity by adding more hosts, more Nova hosts. We wanted to be able to scale performance, storage performance, and by just adding more SSDs. So if you add more SSDs to your tier 1, it's just faster. And we also wanted to be able to scale our tier 2 storage, so our actual storage, by just adding more disks. Which means that you have a completely independent scalable architecture, and you can scale whatever you want. You can scale compute, you can scale storage, you can scale storage performance. That's completely independent of each other. And that's something that you will not see, for example, with a hyper-converged appliance. So that's why why we actually thought this is a much better idea. It also has no bottlenecks for example, if you would have an expensive EMC sub duplicate, you will have a dual controller there, so all the data enters through one node, and that node can become a bottleneck. So it will just stop after you add like a couple of nodes. There will be a limit. What we use is we use a zero shared architecture, which means that it can grow indefinitely because there's nothing that's blocking nothing blocking. So every host that you add will take care of the storage performance of the virtual machines that are running on that node. So that means that you don't have bottlenecks anymore, so you can just grow as large as you want. Reliability. Well, as I already said a few times, we're running virtual machines for our customers, which means that we need to be very safe with data. We cannot lose virtual machine data, so we have to take into account the fact that it needs to be very reliable. Now, typically we'll have RAID 5, but we said that's not safe enough anymore, especially if you're dealing with large amounts of data. So we use new technologies, like for example, if you use a Swift, well, the push is actually down to a Swift, then you would use three-way replication. With the software we have, we could use forward error correction, for example, which is chopping up things and then storing it across multiple disks. So we've got much better reliability than, for example, just a traditional RAID system. Zero shared architecture, I explained that already. We support live migration, so if you have multiple nodes, you can just move a virtual machine without downtime from one node to another node, so that's all supported. Unlimited snapshots, and we also have something where we take, if you do a write on a node, that's on the SSD. So if you do a write on the SSD of a node, we also copy that across to another node, just to make sure that in case that first node fails, you still have a copy of your data. And that means, of course, that you don't have data loss, no data loss at all, in case one of the hosts failed. Now, I don't know if anybody in the room already had played with Open vStorage, with the old version. No? Well, we've got a new version coming out, and this new version, well, it's going to be released at the end of Q1. This will have much better performance, so we've got rid of the file systems, which means that we can go 3 times as fast, which is a huge benefit, of course. We've hardened it a little bit, so the failures are less of an issue. We also have support for the Seagate kinetic drives, which means that you can just hook up disks to the switch and you've got a pool of storage. So it's a better way of doing storage management. It's a lower cost because you don't have, for example, storage heads. It's just a pool of disks that you're managing. But it's not that well known yet, this technology, but it will be over the next few years. It really is the future of where storage is going to. And of course, we're focusing on OpenStack because it's booming.
Which version of NFS are you using?
The NFS v3. That's VMware. VMware doesn't support v4. It would be good if they would support v4, but they don't support it. So that's a problem. Everybody is asking for it. Everybody is begging for it, but they're kind of they don't want to listen.
Yeah, you might do better with PNFS.
That might be an option. Yeah.
Could you explain something about the encryption? Is it built into the Seagate kinetic drives, or you guys do anything about the encryption?
So what we do is we build inside the host. There is a layer that we build, a software layer, which actually talks to those kinetic drives, and we are taking care of the encryption and the compression. So that means that you can take in VMware you have a data store, which is like a set of disks. While we have the same concept, which we call a vPool, and a vPool you can turn on encryption and compression and forward error correction, so splitting it over multiple disks. You can set it for that vPool, and then of course it will do encryption, so it will take the object, encrypt it, and then store it onto the Seagate kinetic drive, which means that it's completely safe. You can't steal it. The Seagate drives, I actually learned this on Monday, the Seagate drives have something built in also, where they have security, so if you yank one out and you take it away, you can't do anything with it because it's also encrypted.
So it's part of the solution?
It's part of our solution.
You don't have to take care of encryption outside?
No, you don't have to take care. We take care of the encryption. You can, it's like with a checkbox, add encryption, disable encryption, add compression, disable compression. That's things that our software takes care of when you use the kinetic drives.
Okay, now currently we use S3, server-side encryption on S3.
And S3,
so is it something similar?
on S3 we do not support it. So it's only for the kinetic drives that we support this kind of functionality like the encryption. But of course you could use the encryption in S3 or
What kind of encryption are you doing on this?
That's a good question. I have no idea. I have no idea. I know that we are using for compression. We're using the one that's Google made, but I don't know for I don't know. Actually, I don't know it, but we can really change it on the fly. So you could specify, and now I'm talking like really internals. What we could do, for example, is we could write something and later change, like in the middle, after like you've done like 1,000 blocks, and after that you change the encryption. That's even possible because we store like whatever encryption method we use with a block, or with an object, we store that together with the object, which means that you can do translations and do all kind of key combinations. But that's not something that we expose in the GUI. That's really something for like administrators, or when you really want to deep dive, or when you have a large cluster, then you can do this kind of things like to optimize or something like that. But
so do you use any third-party product for encryption, like Word Matrix or SafeNet products? Or you just build it yourself?
I have no idea. I don't know the detail of that. So
okay.
I can find it out. Let's discuss afterwards.
Sure.
Give me your name and I'll look it up.
I'll do it. Thank you.
Most of the drive manufacturers now support data encryption at AES 256.
AES 256.
So the SSD manufacturers and now all the new, like Seagate, those guys, they support that already in their firmware. Right? So you would have to have a key manager.
Right. So one of the problems is like Amazon, they also say that it's already, drives are already encrypted, but they also recommend to have a sort of second level of encryption for the application layer, which is what we are doing right now using SafeNet or Wallet. I'd be interested in more details over there.
Yeah.
Thanks.
Okay. Further down the road, what we're looking at further down the road is to build a deduplicated read cache across all the hosts, which means that we take all the SSDs inside every host and we turn it into one big deduplicated cache, which means that if you have a virtual machine on the first host, it could be that it gets its information from like another host, the SSD of another host, but that means that you only store the data once across the whole cluster in the cache, which means that you make a better use of that cache, which makes it even faster. We've got a lot of options to store things, which is even faster than it's the fastest way of storing things, because you can get much more data inside there. That's what's coming over the next few months, and of course you can just scale that by just adding more SSDs. So that's really where you will have a benefit from. If you add an SSD, it will be added to that pool, and it will go much faster.
Is the block size changeable, or is that static? And why did you choose 4K?
The block size is 4K. The reason why we choose 4K is because it allows us to do deduplication in a really good way. If you use 64K, for example, you have a much smaller chance that that block will be referenced multiple times inside a virtual machine. So if you go with 4K, the smaller the block, the more chance, of course, that you will have a cache hit. Of course, if it's too small, then your metadata will just explode. So it's kind of finding the right sweet spot. We went with 4K. It's typically something that you will see with storage systems. If they can manage it, that's like a typical use case for a storage system. Like if you do I/O tests and things like that, it's typically with 4K blocks that they do that. So it's like the the virtual machine sweet spot, let's put it like that.
Thanks.
The new SATA drives too, that's kind of the default. The new SATA drives as well, like the hammer drives and things like that. I think it started with shingle drives. 4K is like their native block size.
Okay, so people are probably wondering, okay, you've been spending the first, I don't know how many minutes, I'm already busy, with talking about vStorage. So what about OpenStack? Well, I kind of already gave it away of what our position is, referring to OpenStack. But this section will go about storage in OpenStack and how do we see vStorage fitting in. Let's start with the slide that I first showed, the slide about object storage and block storage. Again, you have the left side, the right side. If you talk OpenStack language, we will see that it's on the left side Cinder, on the right side you've got Swift, the object store. Now, I already said that there's a line between those two, that there's sometimes barbed wire between those two. It's the same thing for the projects within OpenStack. It's like these two don't get along, don't speak with each other. It's something OpenStack, I guess. So, for the people who are new in the room and don't know what OpenStack Swift is, small summary. So, OpenStack Swift is designed to store large amounts of data. So, it's used in PayPal, eBay, Disney is using it to store large amounts of data. And it's typically unstructured data, so it can be anything. So that's what it's used for. The way how they make sure that they don't lose data, because for example, the commercial version of Swift, which is called SwiftStack, says that they never lost data. They do that by just replicating, which means that if you put in a piece of data, so the red thing at the top, that will be picked up by a proxy server, which is offering the API of Swift, and it will store, that piece of software will store it on 3 different nodes inside the cluster. So if you have multiple nodes, your object will be on that disk, on that disk, and on another node, like on 3 separate nodes, which means that the chance that all 3 of these disks fail is slim to none, which means that it's very safe to store. So it's really scalable, so if you want more storage capacity, you just add more of these storage nodes, so you add more disks. If you want storage performance, you add more proxy servers, so you scale up the API. They do 3-way replication, as said. You could change it to whatever kind of replication, so it's, but the default is 3-way, and they have erasure coding on the roadmap, which means that if they would support it, you would spend half of the amount of hardware here at the bottom. So that's a good thing. Now, the good thing about Swift is also that it's easy to manage. The only thing you can do is do puts and gets. And there's no rates to manage, there's no volumes to manage. It's very easy. It's really made to be as simple as possible. Now, on the other hand, we have Cinder. And Cinder, that's where the virtual machines get their volumes from. So you can create volumes, you can snapshot a volume, you can list, delete volumes, things like that. You can manage migration of a volume, for example. That's all taken care by Cinder. Now there's 2 ways you can use Cinder. First way is using local disks inside your Nova host, which means that you're basically using the disks which are in the host, as I said. The other way is using a third-party application or third-party software, which means that you will have to use a Cinder plugin, so it's very extensible, Cinder, and then you can use, for example, something like a NetApp or an EMC or like a ClusterFS or Ceph, for example. That's the thing that we already discussed earlier before. Now, are there any people in the room who use Cinder with local disks? Okay, well, that's really a management nightmare, because what happens, so you have here your Nova compute node, you have your virtual machine running here, and it has one disk here on the same node, so these two belong together, but it also has a disk over here, so your virtual machine, which is running on node 1, has a disk which is running on node 4, which means that if this node goes out, you lose a disk inside the virtual machine, which is running inside host 1. So that's not typically what you want if you want to build something scalable, something highly reliable. That's not something that you want. And it's also a management nightmare. Just, okay, I've had here all the SCSI stuff. That's a nightmare to manage, so you don't want to do that. Now, of course, most of the people will not do that. They will not use local disks. So they go for something else. So you have your Nova. This is where your virtual machine is running. So Nova provisions your virtual machine. Your virtual machine gets the block storage from Cinder. And then you've got like 2 different projects, like Lens, which is the image store, and Swift, which is the object store. And Swift is used to store, in the case of OpenStack, Swift is used to store backups, snapshots, and things like that. It's like a dump of data, or it's like the garbage, or not really garbage. It's like the place where you put your snapshots, like the final resting space. It's cheap storage, so it's highly reliable. So you're glad that you have that. Now, if you have your local storage, which I already said, that doesn't work. So you need something here underneath Cinder to give actual disks, or that presents itself as actual disks. So what a lot of people will do is they will use a Cinder plugin, and then they will use a SOM or a NAS, like an EMC or a NetApp, to actually give storage to the virtual machines. So the virtual machine talks to Cinder, and Cinder uses those physical drives inside the NAS, inside the NetApp or the EMC for its storage. But that's really crazy, because you're managing 2 storage platforms. Just think about it. You're managing 2 storage platforms. You've got something, a SOM or a NAS, which is expensive, and you have a second, highly reliable, highly scalable storage platform inside your cluster. This is insane. It's having 2 storage platforms that you need to manage. So, of course, if you're smart, then you say, okay, why don't we put Swift underneath Cinder? That makes sense. So we already have that scalable storage. So why don't we use that? Because that has this. Let's put that underneath Cinder. Well, that doesn't work. There's a few reasons. First reason is, for example, you use eventual consistency inside Swift. So to explain eventual consistency, if you store something inside Swift, so if you write something to Swift and you update that object, and later you ask it back, it might be that you get the first value back instead of the last value. And that's not something which really works with hypervisors. If your hypervisor can't work with that, your hypervisor just expects to have the right data always. It cannot work with that. So what you could do is, you could ask VMware to change that. It's not going to happen. It's way too hard to do that. It takes ages just to make sure that your applications can use that eventual consistency. It's a completely different mindset of how to program. So VMware will not change it. KVM will not change it because it's too difficult. So the second reason why you can't use Swift underneath Cinder is it's scalable, but it's slow. It uses SATA disks, so those slow disks, to store things. It's network connected, so it's already a couple of hops down. You've got those proxy servers in between, which add latency. And latency, that's really not a friend of virtual machine storage, or for virtual machines. It's not a friend of virtual machines. You need to have low latency, fast storage. So that's the second thing why Swift underneath Cinder doesn't work. And the last thing is, well, remember that slide about objects and blocks? Well, this comes back. You've got objects and you've got blocks, and that's completely two different things. It's like cats and dogs. They don't get along. They don't talk to each other. They don't understand each other. But of course, why don't we sit in between? So you have your scalable object store, which is called Swift, which is by default in OpenStack. You have vStorage on top of that, which is underneath Cinder. So we have a Cinder plugin. So if you have your virtual machine and you take a snapshot, that will call the Cinder snapshot API. This will, for example, be transferred to vStorage, which will there call the snapshot API in vStorage, and we will make sure that the objects or like the storage containers that we store inside on top of Swift are snapshotted, are having some marks so that you know that which one is in which snapshot. So that's kind of why we think that OpenStack and vStorage are a great combination, because it finally allows you to use that object store, which is highly scalable, highly reliable. Sounds like I'm a sales guy for Swift. Inside OpenStack, you can now use it actually to run virtual machines on top, which is something new, which is something that has not been done before. Okay, if you think this is interesting, it's an open source project, so you can get started with it. Only thing you have to do is go to Bitbucket, and you can get started. To install vStorage, it's apt-get install vStorage. That's the only thing you need to do. We have a free and open source, we have a free and open community. So that means that if you just register yourself, you can get support from engineering. Everybody from engineering is on that support forum. I'm on that support forum. We've got other people who are using the software, so there's a lot of knowledge sharing. And of course, you can contribute. We're building out, I don't know how you say that in English, we're building an active community. For example, things that are being done by our community is the porting of vStorage to CentOS. Currently, it's only running on Ubuntu. The reason for that is 50% of the OpenStack environments are running on Ubuntu, so we said, okay, let's develop for that first. And we have now a community, a set of community members who are porting it to CentOS. We get bug fixing, we get proof of concept code, for example, from our community. So the open source way really works for us. Now, of course, if you're not happy with open source or you don't feel comfortable, you can get just a solution, like an vStorage-based solution, which means that we will ship you hardware and software, the vStorage software, and then it's up to you to put that underneath OpenStack. So that's basically like you would get a sub, but in this case it would be vStorage that's delivering that functionality. And of course you get monitoring support, very low cost, things like that. And if you really don't want to be hassled with managing infrastructure, you can also get the appliance, the converged-based appliance, which means that we'll ship you the compute nodes, so the OpenStack Nova compute nodes. We will also ship you vStorage. We will also ship you your storage, so the kinetic drives. And that will come with an OpenStack version that's supported, so we will help you with setting up OpenStack and things like that. And of course, a supported vStorage version, monitoring support, everything that you want. So this is basically something that competes with the likes of Nutanix, like Averail. The only thing is that we do it at half the price. So that's where we make a difference. Okay, so that's it for me. Just go over some pointers. It's hyper fast. It's highly scalable. It's very reliable. We support unlimited snapshot, things like that. You can do live migration. It's got a very low cost management overhead because we do things VM-centric. So it's really the way forward to manage your OpenStack storage. Okay, thank you very much for your attention. If you would have questions, I see somebody raising his hand. Let's
questions.
But last question is, how do you compare the pricing structure on S3? The pricing structure around S3, because we have seen AWS reducing the prices every now and then.
Mm-hmm. Yes.
So how do we convince people that yes, this will be lesser than or cost effective than S3 pricing?
It will be less. We have for current, I don't know by heart how much it will be less, but let's say that, let me think, for 40, it will be less, and it will be significantly less. Let's say, I'm now guessing it's between 1/3 and one half of the storage. That's like the figures that we're trying to aim at. So that's like where we are. But we are not really competing with Amazon S3 because we don't give object storage. We could perfectly build something. vStorage is perfectly capable of using Amazon S3 as backend. So it's a little bit comparing apples with pears, but I know that if you take the Amazon pricing and the EC2, I don't think it's EC2, or like the virtual machine pricing, that it's really significantly lower. And if I'm not mistaken, I'm going for 1/3, but I'm more in the open vStorage space, while the converged appliance stuff, that's like I'm the open source guy, so I'm not really that involved with that department when they do that kind of stuff. So I think it's around 1/3, if I'm not mistaken. It could be 1/4 or 1/3.
So, full disclosure here, before I came to Strata, I was the CTO of NetApp's public sector. And believe it or not, we were shipping FlexPods, if you know what a FlexPod is, with the UCS and the little control plane with the FAS box and the big E-Series stuff in the back end. And we were able to sell those things for like the Hadoop thing I did. It was about 3 cents a gigabyte per month for the whole thing, of getting the equivalent of like EC2 and EBS for the price of a little bit more than S3. So Amazon's not the cost leader. That's the thing you need to understand. I mean, they're not, especially when you start rolling in the bandwidth charges, they're not the cost leader.
You're absolutely correct. Amazon sounds cheap, or it looks cheap if you're very small, but as soon as you've got a significant amount of hardware, it's much more expensive.
And their performance is horrible. I mean, you can't drive a lot of performance, through those. I mean, compared to something like this, or a NetApp system or something like that, right? So, yeah.
So speaking of that, are you guys exposing this?
That's good.
So speaking of that, are you guys exposing the S3 protocol from Open vStorage so that we can address, you can add and create S3 containers on-prem?
No. No. The layer of software that we've written is optimized just for the block storage that we're using. So while we technically could offer like an Amazon S3 interface, why we could do, for example, like iSCSI interface. At the moment, we don't do that because we really want to specify a limit to that. We try to just do the block storage. That's the thing that we want to do. We don't want to become the next generation object store. There's already a lot of people in that market, and we try to keep away from that market. So that's why we don't do it, for example. But it would not be a problem. The kinetic drives, it would not be a problem.
If you think about this, in AWS terms, this is like running your EBS storage connected through S3, which you can't do in AWS, and Glacier, right? Mm-hmm. So you would get the block interface that your applications are used to, and it would just automatically be storing out in S3 and Glacier. You can't do that in AWS, right? What they're doing here is quite unique from that standpoint.
You can't do it with any other objects, real object store. You can't do it with any other object store. None of them have these capabilities. We're really unique in this field.
So, who are the biggest users of Open vStorage?
Who are the biggest users? Well, first of all, we ourselves are the biggest user of it. We have a lot of interest from telcos, from hosting providers, but that's then more for the complete solution. There's also a big Chinese company who's investing a lot of resources, like community effort resources, into this. So it's taking off. But this is one of the reasons why we're here. We are from Belgium, so we are from Belgium. It's very hard to get known as startup in the US. So that's why we're here, to make sure that everybody knows about Open vStorage, what we're doing, what kind of hot technology we have. In order from somebody else, we are unique in this kind of thing. So it's a great future which is promising us. And for example, just the fact that the Seagate Kinetic or the Seagate's people are really loving this kind of thing. We are the only ones who are using their kinetic drives to build block storage. What other people are doing they are building object storage with them. We are the only ones who are doing that. So we get their support from a vendor like Seagate. So that means that it's got a lot of things going for us, of course.
Anyone else?
Any more questions? Okay. I'll be around in the room later on, so if you're too shy to ask questions in public, you can always come through. Okay, thank you very much for your attention.
Thank you.